So here is a question from electromagnetic theory. So what it is asking is a coaxial RF cable has characteristic impedance of 50 ohms. So coaxial RF cable we know, right? It's basically a cable, okay, and it has a core inside. Now this cable, what it is saying is characteristic impedance. That means Z naught is 50 ohms. Okay, so this is what is provided, and then it says nominal capacitance of 40 pf per meter. Like if we consider a length of 1 meter, the capacitance that is seen is 40 pf. So this is 40 pf per meter. Okay, now what is asked is what is the inductance of the cable. So basically inductance also will get per meter, considering that we are considering a capacitance of uh, in per meter, right? Now characteristic impedance of a particular media is calculated by using root of L by C, right? So now we have Z naught here, right, which is 50 ohms, and then we have capacitance. Now let us calculate the C. So from here, L by C is equal to Z naught square, right? The square root goes the other side, and then L is equal to Z naught square into C. Okay, so Z naught is given by 50. So L is equal to 50 whole square into 40 PF. P is nothing but 10 power minus 12, right? So if we consider this, if it's 25 into 4, and if you all consider 10 square, 10 cube into 10 power, so this comes to 10 power minus 9, because 10 power minus 12 into 10 cube gives 10 power minus 9, and then 24 are 100. 100 is 10 power minus 2. So 1 into 10 power minus 7, which basically is, if we take out 1 10 power minus 1, which is 0.1 micro henry per meter. So the inductance per length of this coaxial cable is 0.1 microhenry per meter. So any coaxial cable characteristic impedance, if inductance and capacitances are given, the characteristic impedance can be calculated using this formula, and any question in this category can be solved this way. Thank you.